Welcome once again to my channel Blue Chip Finance, and once again we are going to take one more question related to critical path calculation. So let's start the video. So the following represents a plan for a project. Here on the extreme left column there are different job numbers, 1 2 3 4 to 11, and in next column there are predecessors, and remaining 3 columns are related to time: optimistic time, most likely time, and pessimistic time. And you are required to construct the appropriate network diagram, and after that we will try to identify the critical path, and after that we will calculate the expected completion time for the project, and at the last we just talk about the probability that the project will be completed in 30 days or less. So first important step is to draw one appropriate network diagram. So let's start that there is no predecessors for 1, so we just draw one line from 1 and just ignore these numbers. These are just node numbers, so we just draw one line from here, and after that second job, third job, and fourth job, these 3 jobs are starting from where a job is ending. So that is the mean of predecessors. So here 2, 3, and 4 jobs are starting from where a job is ending. So after that 5th job is starting where second job is ending. So 5th job, as you are seeing here, that second job is ending here at node 3. So from here we started 5th job, and after that 6th and 7th jobs are starting from where third job is ending. So here 6th and 7th job are starting from where third job is ending. So third job is ending at node 4. So from here we are starting 6th and 7th jobs. Okay. So 8th job is starting from where 5th and 6th job is ending. So 8th job is starting from where 5th and 6th job both are ending at node number 6. So from here we draw one line that represents the 8th job. After that 9th job is starting from where 8th job is ending. So here 8th job is ending here at node 8. So from here 9th job is starting. After that 10th job is starting from where 7th job is ending. 10th job is starting from where 7th job is ending. So 7th job is ending here on node 7. So from here 10th job is starting. And why we joined this 9th and 10th jobs? Because of that where 9th and 10th job is ending, from here 11th job is starting. So that is why here 9th and 10th job both are ending at node 9, and from here 11th job is starting. So your starting node is 1 and your ending node is 10. So that is the way that how can we make the network diagram. It's up to you that if you use any other structure of network diagram, you can make it according to your own choice. But remember these things which I discussed, that how can we start the job line. We just focus on the predecessors. It is very important to make correct network diagram. So now the next point is to identify the critical path. That is the long process, but before going to calculate the critical path, one is to calculate the average and second is to calculate the variance. So in previous video I already discussed in detail with you about the formulas of average, mean and variance of the time consumption of optimistic time and most likely and pessimistic time. So here formula for mean is optimistic time plus 4 multiplied by most likely time plus pessimistic time divided by 6. So formula is applied here one by one. For example, I discussed with you one or two job mean steps to calculate the mean. For example, first of all, optimistic time is 2 plus 4 multiplied by most likely time, that is 3, and plus 4 is your pessimistic time divided by 6 equals to 3. Similarly, optimistic time is 1 plus 4 multiplied by most likely time 2 plus pessimistic time 3 divided by 6 equals to 2, and so on. After the calculation of mean, the next step is to calculate the variance. So here variance formula is the pessimistic time minus optimistic time divided by 6 whole raised to power 2. So pessimistic time is 4 minus optimistic time is 2 divided by 6 raised to power 2 equals to 0.11, and in this way we can calculate variance for each job. So after the calculation of mean and variance, now the next step is to apply the mean to the network diagram. So here as you are seeing here that it is the same diagram. I used 2 to 3 times or maybe 4 times the same diagram to make it easier or understandable for you. Otherwise you can just do whole process within the same one diagram, but I used here more than one time the same diagram for your convenience of understanding. So after the calculation of mean, we just noted down here relevant means to the activities. So job number 1, 2, 3, 4 and so on, and their relevant means are given here, and we just apply means here. So activity or job number 1 mean is 3, so we place 3 here. Job number 2 mean is 2, job number 3 mean is 6, job number 4 mean is 5 and so on. So in this way you can apply the means. After that, in third diagram here, once again we just copy or pasted here the same diagram once again, but in this step we will calculate earlier start time or forward pass and end time or backward pass. So 2 steps we will calculate here. So in previous video I discussed with you in detail that how can we calculate the earlier or forward pass and backward pass. So first of all we focus the lower rows and just ignore for instance of the upper rows. So we start from 0 when we calculate. First of all we will calculate the forward pass time. So we take a start from node 1 and take 0 here, and after that 0 plus average time 3 equals to 3, and from here 3 plus 2 equals to 5, and here two more activities are originating from here, that 3 plus 6 equals to 9, and 3 plus 4 equals to 9, but we did not 3 plus 5, okay, 3 plus 5 equals to 8. So from here where we left, here total is 5, so 5 plus 3, or here one more activity is coming here, that 9 plus 2 11, and 5 plus 3 8. So which one is maximum? 9 plus 2 11 is maximum, 5 plus 3 8 is less than 11. So in calculation of forward pass, always choose the maximum sum. If there are different choices for you coming to the same node, then you will have to choose the maximum time. So that is why here we took 9 plus 2 equals to 11. So from here 11 plus 4 equals to 15, and 15 plus 5, as you are seeing here, and different nodes are coming here, as you are seeing there. 9 plus 7 equals to 16, and 16 plus 4 equal to 20. So that is why we consider 20 here, because 20 is the maximum sum of the possible combination coming to that node. And from here 20 plus 6.84 equals to 26.84. so that was the ending node. So in this way we can calculate the forward pass. There are different directions, as you are seeing here. One direction is going starting from 1 to 2, 3, 6, 8, 9, 10. One direction is 1, 2, 4, 6, 8, 9, 10. One direction is 1, 2, 4, 7, 9 and 10. So there are a lot of different directions in which you calculate forward pass. So one thing must remember, that whenever you calculate the forward pass, always take maximum sum. If there are different possibilities or choices of the combination coming to the same node. So after the calculation of forward pass, now we come to the calculation of backward pass. So from last node, as you take start from the first node in the calculation of forward pass, whenever you calculate the backward pass, start from the last node. So what is the forward pass maximum sum? And that is 26.84. so take this 26.84 in the first backward pass. Now we will discuss the upper rows and just leave bottom rows for instance. So 26.84. now in the calculation of backward pass, now you must remember that if there are different choices or different possibilities of sums, first of all we will subtract rather than adding or summing up. And the second thing, that if there are different choices for different combinations coming to the previous node, then you always take the minimum sum, just an opposite of the forward pass. So 26.84 minus 6.84 is equals to 20, and from here 20 minus 5 equals to 15, and 15 minus 4 equals to 11, 11 minus 3 equals to 8, and 11 minus 2 equals to 9, and from here 8 minus 2 or there is one another possibility that 9 minus 6. So 8 minus 2 or 9 minus 6. 8 minus 2 is 6 and 9 minus 6 is 3. So we will consider the least value. So we will consider here 9 minus 6, 3. So 3 minus 3 equals to 0. So that is the point that if the last backward pass is equals to 0, then you are going correct. So in this way we calculate forward and backward pass. It needs practice. So after that, now we define the critical path. So there are different possibilities that if we are seeing here that there is one possibility that node 1 to 2, 2 to 3, 3 to 6, 6 to 8, 8 to 9 and 9 to 10. That is one possibility. Another possibility that 1 to 2, 2 to 4, 4 to 7, 7 to 9, 9 to 10. That is another possibility to complete the project. And there is one more, that 1 to 2, 2 to 4, 2 to 6, 4 to 6, 6 to 8, 6 to 8 to 9, 9 to 10. So there are a lot of different possibilities to complete the project. So here these are different critical paths. So as you are seeing here that we noted two different directions, 1 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 9, 9 to 10, and 1 to 2, 2 to 4, 4 to 7, 7 to 9, and finally 9 to 10. So if we calculate the average time for these different critical paths, so 3 plus 3 plus 6 is equals to 9, and 9 plus 7 equals to 16. 16 plus 4 equals to 20, and 16 plus 10, 26, 26 and 11. So 1 is the possibility, and one another possibility that we go from direction 1 to 2, 2 to 4, and then 6, 6 to 8, 8 to 9 and 10. So here I noted down that first critical path, that 1 to 2, 2 to 4, 4 to 6, 6 to 8 to 9 to 10, and 1 to 4, 1 to 2, 2 to 4, 4 to 7, 7 to 9 and 10. And their average times are given here. So for one possibility, there is, if we follow this path, then our possibility to complete this work is 27 days, that 3 plus 6 plus 7 plus 4 plus 6.84, 26.84, or approx 27 days. So that is your critical path. After that, what is the probability that you complete your project within 30 days? So just take this critical path mean and variance as we calculated previously. So if we follow this path, 1 to 2, 2 to 4, 4 to 7, 7 to 9 and 9 to 10, once again we just focus 1 to 2 and 2 to 4, 4 to 7, 7 to 9 and 9 to 10, 1 to 2, 2 to 4, 4 to 7, 7 to 9 and 9 to 10. So here for their particular or specific critical activities, relevant means are given here, 3, 2, 5, 7, 5, 4, and variances are given here, 0.11, 0.11, 1.78 and so on, and their sums are also given here. So just apply the formula x minus mu divided by standard deviation. So x is your required days. For example, you want to assess the probability of completion this project within 30 days, so that is 30, and minus mu is your mean, that is 26, and standard deviation is simply under root of this variance 5.67 and 1.67. so just go to the normal distribution Z distribution table and locate this 1.67 and 1.6 as you are seeing here, that in rows 1.6, and focus the column number 7. So in 7th column the value is 0.9525, so 95.25% chance that you complete your project on or before 30 days. So here I just take one question for you, that you just draw this network diagram by yourself and determine its earliest start or earliest finish and latest start and latest finish time of each activity, forward pass and backward pass, and find the critical path. So thank you very much. Take care of yourself and other persons around you. Thank you.